episode of the Schnar Science segment, or Triple S. If you're new to the show, I'm Brian, and I'll be your professor for today. Before we introduce today's topic, we must meet my lab assistant. Say hi to the new faces, Jared.
Hi, new faces. I hope you enjoyed the show. Hey, Professor.
Yes, Jared.
We have fan mail.
Really? Our first piece of fan mail. Here, give it here. This comes from twins Haley and Logan, and it reads, Dear Professor, can you explain what H foods equals NQ and vaporization NQ and Q equals MC delta T has to do with the hydrologic cycle? What the Well, what an opportune time for me to bring in my newest invention. Meet Jade.
Is that my laptop?
Yeah, I upgraded her.
Her?
Hello, Jared. I understand the confusion, but I must inform you that I have become much more efficient thanks to Professor.
My computer can talk?
Indeed, and so much more, but right now I'm here to help solve this dilemma.
Thanks, Jade. She's here to help us with anything tied in with math and formulas. All you need to do is ask her about which formula.
What does this mean?
Oh, now that makes sense. Can you print 26 copies of that, please?
Of course.
Why are you doing that, Professor?
It's for our friends in the audience. That doesn't matter, though, because we're tying all this into the hydrologic cycle. The hydrologic cycle is the cycle of water in our biosphere. It all starts with glacial ice, like the fields up in BC. When that starts to melt, or when water flows across the surface, the water flows into rivers that usually end up in the ocean or in a lake. Out of necessity, some water will evaporate.
Doesn't that require high temperatures?
Not always. Sometimes water just becomes gas over time. That gas goes up to form the fluffy clouds that make up the spaceships, dogs, or the face of God that you see every single day.
Okay, I see.
Then, when that cloud accumulates enough water, the water becomes too heavy to remain suspended, and some of the water falls to the earth as the precipitation you see everywhere.
I think I can explain the heat transfer bit.
Okay, go ahead, see what you got.
All heat transferring is self-explanatory, but there are some rules. For example, when ice melt, heat energy from the surroundings is rushed to equalize the temperature of the ice cube. Heat always heads for the cold, so technically you should say you're letting the heat out when someone opens the door on a cold winter day and stand there soliciting you some plastic cheese grater that you never wanted. What's really odd is when water freezes, the thermometer will stay at 0 Celsius even if the outside temperature is -30 until the water freezes completely, after which the ice then drops to the ambient temperature outside.
Professor, people might be asking, what does freezing have to do with the hydrological cycle?
Well, dear viewers, I have a solution to the problem. Jake, can you show the picture?
Of course.
Thank you. As you can see, when the water at the Earth's surface runs off into rivers, streams, or oceans, they eventually evaporate into the clouds and then the water rains. I said that before, but when water freezes, it has a very odd property. Ice is less dense than liquid water, which is quite paradoxical, but explains how ice flows. Now, when the ice melts, it becomes able to evaporate into the air. However, glaciers can and do move. So when they melt away, they create new lakes and ponds, new places for clouds to form.
But what about water that appears outside my window when it hasn't rained?
Well, that's condensation, which is basically when water becomes too cold to be a gas and condenses to the closest coldest surface. You'll often see it after a fog has passed through, since all a fog is a low-lying cloud.
Sorry to ruin the fun, but you forgot to cover.
HFOOS and HVAP? I think you should explain that.
Okay, HFOOS is the heat of fusion, or the amount of heat required to convert a solid at its melting point to a liquid without more heat. Quickly note that heat is the energy of gas molecules. The slower and less energy, the less heat. The equation HFOOS equals NQ second half represents the quantity of thermal energy in kilojoules, Q, and the amount of substances in mole, N.
Mole is the unit of measuring which entails how much a mole of a substance weighs. A mole, by the way, is 6.022 times 10 to the 23rd power molecules. Or in the case of water, it's just 18 grams, or if you want the actual amount, 18 milliliters.
Excellent summation, Professor. Now heat of vaporization, or HVAP, for the people who love contractions.
Like me!
Similar, but entails the amount of heat needed to turn liquid to gas without increasing temperature. NQ is the same here.
This ties in because water is the only substance that exists in all three states, your solids, your liquids, and your gases. Knowing exactly when water melts and water boils allows us to guess at how quickly ice caps are melting and how much water is evaporating. Now it's time for my spiel. When we need to see how quickly rivers are shrinking and how quickly ice caps melt, we require the previously mentioned HFOOS and HVAP. But why why is that important? Well, when ice melts at the insane rates it is melting right now, and how quickly lakes are melting away, we can build a picture of what's to come. And what we predict, it isn't good. Come 2100, we can expect 1 million species, which is over 1/8 of the species that we believe are alive right now, to be extinct. The equator will become too hot for us to live in, even with liquid nitrogen AC units. Saskatchewan and Alberta will become the new heartland, and most of the United States will become a desert. The hurricanes we see today will become monstrous typhoons that can engulf half a continent, destroying everything in their paths. If we don't find solutions soon, humankind will be roasted to extinction. Don't forget to be awesome.
We'd like to give credit to many of the sources that made this possible. Mr. McMillan for the ideas and assignment for the video.
Oh, and I forgot one more thing. We gotta thank this lovely lady for being our photographer, and for lab assistant Matt. Hello! Hello! For being, well, the result of some sort of brain transfer gone wrong. I think this is the person who helped us with our script. And Matt still being a creepy person.
Outtakes. Enough said.
Hello and welcome to another episode of the Schnar Science segment.
Okay, yeah.
Hello and welcome to another episode of the Schnar Science segment, or Triple S. If you're new to the show, I'm Brian and I'll be your professor for today. Before we introduce today's topic, we must meet my lab assistant. Come say hi to the new faces, Jared.
We should say come to say. Just stop it. We can't say.
Hydrologic cycle is the cycle of water through our biosphere. It all starts with glacial ice, like the fields up in the sea. When that starts to melt, or when water flows across the surface, the water flows into rivers that usually end up in an ocean or in a lake. Out of necessity, some of that water will evaporate.
Doesn't that require high temperature?
Not always. Sometimes water just becomes gas over time. The gas goes up to form the fluffy clouds that make up the spaceships, dogs, or the face of God you see every day.
I see. All heat transferring itself is self-explanatory, but there are some rules. For example, when ice melts, heat energy from the surroundings is rushed in to equalize the temperature of the ice cube. Heat always heads for the cold. So technically, you should say you're letting the heat out when someone opens the door on a cold winter day and stands there soliciting you some plastic cheese. Alright, H first is the heat.
Oh crap, that's Jade!
Oh, mother, son of